Right, it's recording. Exercise 2F is called Family of Straight Lines. The essence of this exercise is for you to be familiar and be okay with that an equation doesn't always have to have numbers. It can represent a hypothetical situation. So here when we refer to the term family of straight lines, so this line here, family of straight lines, what we mean is to consider all of, and fill this in, all the possible straight lines the equation could be. Now you're starting off with straight lines in chapter 2, so hence it's family of straight lines. Later on it's called family of functions or family of curves because it could be anything. It could be a variety of possible quadratic equations, could be a variety of sine functions, exponential functions, hence we call it a family. So here's an example. Y equals mx plus 1, okay? You can't really sketch this equation yet, and I'll show you with Desmos to prove my point. If I go to Desmos now, and I write y equals mx plus 1. See, 1 is an actual number. That tells us the y-intercept will cross at 1. So that means if I zoom in on the y-axis, I expect that this straight line will cross through 1. But notice it says here add slider. Why is it add slider? Because we don't know what m is. There's an infinite amount of possibilities of what m could be. So that's why they say, well, let's add a slider and let's see what if m was 1? What if m was 2? What if m was 3? What would it look like? And that's called family of curves, or family of straight lines. So if I add in the slider, so if m was 1, then it would be y equals to 1x plus 1. This is what it looks like. A gradient of 1 means 1 to the right. So run is 1, rise is 1. You see that? So this is an example of one possibility of what m can be. But m could have been 2. So if I just move my mouse here, and I said m could be 2. So it goes, that's 2. M could be 3. But all the changes that you're seeing right now, how the line's moving, that's all of the possible straight lines that y equals mx plus 1 can be. So we call all those possibilities, we call that a family. Does that make sense? Yeah, so if I press play, visually, if I change m, this is what the possible lines that m can be, or mx plus 1 can be. This is all the possible lines. The only thing that doesn't change is what? The y-intercept. That was the only one thing that stayed constant, so hence it keeps rotating around 1. What changes is m. And that's what you need to get familiar with, that it's okay to have an equation that doesn't have a number, it's a hypothetical situation. So if I gave you y equals mx plus 1, this is what I'm visualizing. I'm visualizing all the possible equations that could be there, which quadrants it could be, and this is when you do applications, they might say, well, it intersects with this other graph at this particular point, and then you can decipher, well, where should m be then? Should m be negative? Should m be positive? Those are the kind of things that you'll be thinking about. And that's what methods is. Methods is abstract, okay? Abstract thinking. So, hopefully that clarifies what the purpose of exercise 2F is. The purpose of 2F is for you to get comfortable with equations where you do not have the variable. I said that in year 11, this first exercise that you're doing is going to be easy because they still get you to figure out m, and they give you one specific point. There's only one possible equation. Later on in year 12, you will work with infinite possible equations. So it's not m equals 2. It'll be m is possibly greater than 1, or m is between half and 3, something like that. That's what you work with at year 12 level. Okay? So here, what are some properties we can say about this line? Well, one thing I know, just from looking at that line before, what do we know? So I'm just going back to this. What can you tell me? I've got 3 points there. So if I gave to you y equals mx plus 1, what are some things that you definitely know? What do you know? Give me 3 things that you definitely know about this equation. Yeah, that's the most obvious. So we've got y-intercept is equal to 0, 1. So that's a definite thing. So on this graph, I know, even though I don't know what m is, I do know that it's 0 to 1. Notice there's a little detail that I put in that I haven't read out. What's one little detail I put in to the question or the example that I haven't read out?
M is greater than 0.
Ooh, reread that.
Oh, less than 0.
Less than 0. What does that mean? If I said m is less than 0, what does that imply? Hands up. Molly. M's a negative number. So let's turn back to my Desmos because this helps you visualize the problem. If I said m is a negative number, less than 0, then what possibilities that I can have right now? What can I have that you can see that's occurring in this that I should fix? Yeah, the positive section. So when the graph turns that way, that's positive gradient. You can't have any of those lines. So in your mind, if I fix the range now, so the range is, I'm saying it has to be negative. So I'm going to go from negative 10 to, let's say, negative 0.1. I don't know, something like that. Okay? So now if I press play, this is the true possibilities of mx plus 1 if m has to be negative. There you go. Can you see how the graph never goes into the other region? It doesn't go to the positive region. This is what I'm visualizing. So when you have a problem, this is what you visualize and you say, yep, it could be as steep as possible or it could be as flat as possible. As it gets smaller and smaller, it gets really flat. Okay, so back here, what can we say? We know that the gradient, so m, which is the gradient, for those who didn't know, I'm just going to write gradient here. Gradient, or the slope of the line, is negative. What else can we say? So we know that the line can be like this, it could be like this, it could be like this, it could be, I don't know how to draw it, it could be like this. These are all the possibilities of what it could be. What do you think a third point could be? It's a bit obvious. I haven't really emphasized it, but might have overlooked it. This is only important once you get to year 12. There's a few more. That's true too. Yeah, we'd probably add another point there too. Never goes to the third and first quadrant. So I'll add another point. Never crosses third and first quadrant. Oh, sorry. I see what you're saying. That's true. I was thinking more like the line that goes like that. All right. The other one that's most obvious, Molly? Oh, true. That's another one too. I didn't even think of that. With a negative gradient, if it has to cross through the y-intercept, what do we know about the x-intercept? Yeah. The x-intercept is always going to be positive. There's no way that you can draw a line that crosses the y-axis at 0, 1 and have a x-intercept over here. True? Because if I have to draw a straight line, as soon as it hits this side here, negative x, but then a positive y, it has to be a positive gradient. So yes, that's actually a really good point. I didn't even notice that one. X-intercept must be positive. What I was thinking was at year 12 level, you have to determine what kind of function you have. It was a straight line. So one of the things that you definitely know is you got a y-intercept, you got a gradient, and you know it's a straight line because later on you will get quadratics, you could get sine functions, and it's your job to determine what kind of function you have because each function has its own properties. But I love that last one, that x-intercept. That is so key because some of the year 12 problems, they will give you something like that. They'll say something like, explain why the x-intercept is always greater than 0. And then you would have to explain through the gradients, drawing the graph, or whatever it is you have to be able to analyze and determine it. So as you can see, even just from a family of curves like that, the ability to analyze what we just did, that's what year 12 is. At year 11, we're not doing that. Okay, maybe in the later questions, if you try the harder questions, you may start venturing to that kind of thing. Okay, so what kind of questions are you going to do? These are the kind of questions. Now, I'm just going to fill out these points so you can fill it in. In this exercise, you are required to problem solve and explore straight line equations that could have changes to the gradient or the axis intercepts, okay? But the kind of problems you're going to deal with is not as complex as the way we just talked. If you were able to understand what I just described just now and you were able to follow those key properties, fantastic. That is what methods is. The ability that by the end of year 12, you can critically analyze a function without my guidance. That's the goal, okay? So here, let's have a look at what you'll do at year 11. So this is from the textbook, exercise 2F, question 2. Question says, the line with equation y equals 2x plus c, where c is a number, okay, so we know it's a number, passes through the point 311. Find the value of c. What do we do? So they told us this is our equation, so I wrote y equals 2x plus c. They want you to find the value of c if you know that this line passes through 311. What do? Nothing. Yeah, because we know, well, if it passes through this point, then that means when x is 3, when x equals 3, we know that y coordinate has to be 11, according to this rule. Because this specific rule says the line will pass through that point. So, sub it in. Let's solve. You should get 11 is equal to 2 times 3 plus c. 2 times 3 is 6 plus c, and you've got 11 there. How do I solve for c? What do I do? Can I please have, let's go Sion. What would you do?
-6.
Very good. -6 on both sides to balance the equation. 6 minus 6 cancels out with 0. 11 minus 6, which is Luke? 5. Very good. So, finish off your question. It says the line, find the value. Actually, it just says find the value of c. So, you'd say, therefore, the value of c is 5. Okay? So this is the kind of examples that you would be doing at year 11 level.
Instead, if we write the value of c, can you just write like the equation with c implemented in it?
I was going to do that, but I realized the question didn't ask me to find the equation of the line. They just said find the value of c. So if they said find value of c, you could have just done therefore c equals 5. That's fine too. I wouldn't write the equation just because they didn't say. If you do more than what the question asks at year 12, the examiners may penalize you because they think you don't know what the question's asking. So if they said, for example, factorize, and then you factorize, but then you solve the problem as well, then they don't give you the mark just because you factorize. They'll give whatever your last statement was. So if you had, for example, if you factorize a quadratic equation, you had x minus 1, x plus 1. This is what they would have gave the mark for. But if you carried on and you went... solved that and you said x equals 1 and x equals -1, they'll cross the whole thing. Okay, so you got to read the question and say, well, what is it asking? Is it asking to solve? Is it asking to simplify? Or is it asking for, factorizing? So hence, I paused before and I was going to write the equation. I normally do, but in this case, they're only finding the value of c. All right, next one. Let's turn over to the next page. This is, again, from the textbooks. I'm just doing examples. Why am I not doing the examples of your textbook? The textbook has examples, it has solutions as well. I believe I've made videos already for it, so if you wanted to watch it, you can. Most of you will learn it just by reading the examples, so sometimes I do the textbook examples. Here, exercise 2F, question 5. A family of lines have equations of the form y equals mx minus 3. So we don't know what m is. Actually, it says where m is positive. So they're saying that m is greater than 0. Okay, that's what they're saying when they say where m is positive. So we know it's a positive gradient. Now it says find the x-axis intercept in terms of m. So let's break it apart. How do you normally find x-axis intercept? What's the theory? Hands up. Y equals 0. We know that x-axis intercept, we don't know what x is, but we know on the x-axis the y coordinate is always 0. Hence we usually say let y equals 0. So according to my equation, what equation have they given me? They've given me y equals to mx minus 3. The only thing I know is y is 0. So if y is 0, then I've got mx minus 3. Now they said find the x-axis intercept. So they're really saying solve for x. That's what we're trying to find. We're trying to find this x coordinate right here. So if you want to find x, solve for x right now. I know there's an m there. That's okay. Pretend it's a number. How would you solve it if it was a number? What would you do? What's the next step? Let's go with... I got to learn some names here. Who do we have? Martha already chose. Luke chose. Ishan? Move the 3 over. How do we just move the 3 over? What would you do though? Very good. Balance the equation. Minus 3 plus 3 are inverses, so they cancel out. So you get 3 is equal to m times x. But I don't want m times x. I want just x. What do I do, Mete?
sorry.
No, you're right. It is divide. What do we divide?
So it's x.
No, by m. Because we're trying to solve for x. So we're aiming to get rid of m. Sometimes, and this is the first part of year 11, is to get familiar that m is a number. If it helps you, you could have pretended that you had 0 equals to 2x minus 3. If I asked you to solve for x, you would have naturally gone through it, move the 3 across, and then divide both sides by 2 is what you would have done, right? So if that's what you would have done, just replace that 2 now with an m in your mind, and that's exactly what they mean by find the x-axis intercept in terms of m. In terms means that the equation has the m value in it. So if I cross it off, m divided by m is 1, and therefore my final answer is x is equal to 3 over m. Notice there's a condition for m, so just write comma where m is greater than 0. Those little details that you put in is what the examiners look for next year. Okay, it's the difference between the 40 plus and then about the 30s to the 37. It's that little detailed redefining what the equation is. Okay, I'm just going to make this a bit smaller so it looks nicer. Yeah, that looks better. And then I'll just move this down here. There we go, nice and ordered. All right, next part, B. Find the value of m if it passes through the point 0.56. What do we do, Kai? That's okay. Let's pick another person. Who have I picked? Massey. What do you do? So it says find the value of m, so I want to find m. But we know it passes through the 0.56, so what are you going to do? Yeah, because we know that this equation passes through 5, 6 means that when x is 5, y is 6. So what I'm saying is, if x is 5, I know that y has to be 6, just because it says this line clearly passes through that point. So substitute it in. Let's solve. You got 6 is equal to m times 5 minus 3. Solving for m, so here we go. M times 5 is 5m. Minus 3 equals 6. And here you balance the equation like you normally have. Add 3 on both sides. You get 9 is equal to 5m. And to get m by itself, divide both sides by 5. Okay, so therefore m must be 1 and 5. And that's true because it's positive. We know it was meant to be a positive number, so that still checks out. So far, so good. If it was negative, then something's wrong. Okay. Let's go into C then. So this is the examples of what you'll be doing in the textbook. Can you see how we're not really working with the same analysis we did up here before? Yeah, that's the year 12 level where you start to work with x-intercept must be positive. But when you come down to here, you can see you're just solving for m. Okay. All right, C. So this one gets you to think a bit further now. So for which values of m is the x-intercept, so read it carefully, where the x-intercept is less than or equal to 1. This is where you start to think the way that Molly had described before. So think about it. You've got a formula for the x-intercept. But they're saying, what kind of numbers can m be so that you have an x-intercept less than or equal to 1? How would we do this? Anyone have an idea? Hands up. I'll help you with a visual idea. Here's a visual idea. Oh, this is still playing. Look at that. So we have mx minus 3, right? And m has to be positive, so I'm going to change this. I'm going to say it's from 0. Where can I select it? 0 all the way to, let's make it 20. And a jump of 0.2. Okay? So here's what it looks like. So it helps when you can visualize it. So I'm going to do that. Now, these are all the possible graphs that it can be. So I'm going all the way up to 20 and going all the way back. So this is all the positives. So positive gradient, right? What are we saying? We're saying, what should m be, as it's playing around over there, what should m be so that I ensure the x-intercept, see these are the x-intercepts? I don't want it to be more than 1. See that? All those lines over here, I don't want. I just want it between 0 and 1. What can m be? Now you can look at that and you get a sense But we're not about the guess and check. This is easy because you can visualize it. You eventually have to do it in your head and be able to figure it out. So what do we do? How do I get that answer? You can kind of guess roughly where it's going to be to ensure that it's always going to be less than 1.
Do you want to answer 0 is less than m, but m is less than 1? Or equal to?
It's a good start. So you're saying, yes, it has to be greater than 0. So gradient is obviously greater than 0, but it has to be less than a certain number so that your x-intercept is less than 1. So you're on the right track, but we're not truly there. We want to have an idea on how we're going to solve this. All right, cool. I can teach you something. So that example, that question there, that's a sort of venturing into year 12. That's what we do. Okay, so here, remember, why did they get you to do A, B before you do C? Is because A and B helps you to do C. So A, you worked out this is your formula for the x-intercept. That's the formula. Whatever m is, 3 divided by m will give you x, right? But what do you want the x-intercept to be? What's the maximum number it can be? 1. That's what the question said. It said x-intercept is less than or equal to 1. So if this is your formula, x is equal to 3 over m, all I want is that equation, 3 over m, I just need it to be less than or equal to 1. That's all I'm doing. I'm just trying to figure out this bit. Because that bit there, if I can solve this inequality that you did back in year 9 and 10, solving equations, then I can solve the possibilities for m. So here, let's do it. 3 over m less than or equal to 1. How do we solve for m? How do I solve this? So I want m by itself. What do? Yeah, because this is divide m, so opposite of division is multiplication, so times m on both sides. M divided by m cancels out to be 1, and I now have 3 is less than or equal to 1 times m. So what does this mean? What does this mean? What can m be? Yeah, so as long as you choose a number that's equal to 3 or more than 3, you should ensure that the x-intercept is going to be less than or equal to 1. Because remember, this represents the x-intercept. And you're saying, I want the x-intercept to be less than or equal to 1. So let's see if it's true. Let's go to our Desmos. So where's 3? If I go to 3, if I made m equals to 3, let's have a look at the x-intercept. Oh, look at that. So beautiful. It crosses exactly at 1 because 3 divided by 3, if the gradient is 3, then 3 divided by 3 is 1. True? Because the formula says, whatever the gradient is, 3 divided by that. So if you want 1, well, 3 divided by 3 is going to give you 1. But how are you going to get less than 1? Logically, the larger the number, 3 divided by a bigger number makes it smaller. True? So here, you can see that if I changed it to 4, 3.2, sorry, 3.2, that's less than 1. So here we go. So as soon as I went to 2.8, x-intercept is bigger than 1. But as soon as I go back to 3, 3.4, 3.5, you can see it's always less than 1. But that was not with guessing. I did it through analysis of the function. That's what 2F is. And you'll find at 3i, discriminants, this is the kind of thinking you need. Yeah, so that's why I was saying that this is, even if you haven't got it yet, it's okay. At chapter 3, you'll start working more on this. Okay? So there you go. M has to be greater than or equal to 3. M is greater than or equal to 3, and it will always work. So that's all the possibilities of M. And here's your last question. Find the equation of the line perpendicular to the line y equals mx minus 3 at the point 0, negative 3. How do we do this? Here we go. Y equals mx minus 3. That's your equation. You want to find the equation that is perpendicular to this line. So find the equation that's perpendicular to this line. Now, if it's perpendicular, what's the property again? For it to be perpendicular, can I please have Artie? What's the property for perpendicularity? I see what you're trying to do. Some people memorize the property, so M2 equals negative 1 on M2. That's what you mean by flipping. Okay, oh sorry, M2, M1. The property technically is just M1 times M2. If you multiply the two gradients, it should equal to negative 1. So that's our last previous exercise, exercise 2E. If you haven't done that, make sure to do so. These are the properties that you must know from year 10 and year 9. So here, M1 times M2 has to equal to negative 1. Unfortunately, this equation doesn't tell us what M is. It just tells us the gradient is M. So we call that M1 for now. So what would M2 be based on this theory? You know? It should just be this. You don't need a number. You have to be comfortable working with letters here. So just because I don't know what that number is, just call it as negative 1 on M1. Okay, so here we go. I can then say, here's my equation I'm looking for. I'm trying to find y equals mx plus c. That's the equation of a straight line. That's what they asked. Equation of a line. So y equals mx plus c. There's two things that you need to find. You need to find the gradient, but we know the gradient's perpendicular. And based on what Artie said before, this is the formula to find M2, or you can rearrange the original property to get that. And so since we don't know what M1 is, well, that's the gradient for M2, okay? So if that's the gradient for M2, I now have negative 1 on M1 plus C, and that's still an X there. What am I missing? I still don't know what C is. How do you find C? What's another piece of information they've given us? So I've been the point, but you've even realized that that's actually the y-intercept. X is equal to 0, so the y-intercept is negative 3, so we know that C has to be minus 3. But if you didn't know that, you can still say sub 0, negative 3 to solve for C. If you sub it in, negative 3 is equal to negative 1 on M1 times 0 plus C, but 0 times anything cancels out, so C equals negative 3. So what's your perpendicular equation? The perpendicular equation must be y is equal to negative 1 on m x minus 3. Now, if you found that hard, that was question 5. That's what exercise 2F is, and it's okay to be hard. Okay, I don't expect year 10s to jump in and be very fluent with this kind of thinking. But this is what methods is. So if you've asked me at the subject's info night, this is what I tried to explain, that methods is a hypothetical thinking. You don't actually have numbers to work with. You're thinking in a very abstract way, and that's what the difference between specialists and methods is. Specialists more application, you apply, you make it happen. Here you're thinking, well, what if? What's the possibilities? Okay. That's the kind of thinking you'll be getting towards year 12. That's the level that you want to be at without my guidance. Okay. All right, I'm going to stop the video there and give you